So welcome to the second part on resistors. Last lesson we focused on ohmic resistors. This lesson we're going to focus on non-ohmic conductors. So the learning objectives for today, there's going to be two of them. To determine the difference between ohmic and non-ohmic conductors / resistors, and describe the effect of temperature on resistance. So ohmic conductors from yesterday's lesson. If you plot a current versus voltage, then you get a straight line. And if the current voltage graph of the component of the is at constant temperature and is a straight line, the origin, then it obeys the idea of Ohm's law and is called an ohmic resistor. Whereas with a filament lamp, if you plot current against voltage for a filament lamp, you can see that it is bent. There's a curve. The resistance of the filament lamp increases as the temperature of the filament increases. Reversing the voltage, in this case this section of the graph here, reverses the direction of the actual current but does not change the shape of the curve. The lamp in this case does not obey Ohm's law as it's not a straight line, therefore we call it a non-ohmic resistor. Okay, so there are a few examples of non-ohmic resistors I'm going to go through in today's lesson. The first one is a diode. So I want you to pause the video now and see if you can fill in the missing letters, and then pause the video and let's see if you're right. Okay, so welcome back. So a diode only lets current flow in one direction. It has very high resistance in the other direction, so current does not flow in that direction. Okay. So the next example, and there we have a potential difference of 0.6 volts. The next example is a LDR or light dependent resistor. So again, pause the video and try and fill in the gaps, and then we'll go through it together. Okay, so welcome back. So light dependent resistors, or LDRs, have a high resistance in the dark. When light shines on the LDR, it has a low resistance. This makes it easier for current to flow. So, okay, so an LDR, the resistance of the device or the component is dependent on the amount of light on the device. So when it's dark, it has a high resistance. When it's light, it has a low resistance. And there's an example there. When you shine the light on, the current can flow. And the final example is a thermistor. So pause the video now, and then we'll go through it together in about 5 seconds. Okay, so welcome back. So thermistors have, again, a high, it's terrible writing on my behalf, a high resistance when they are cold. When they heat up, they have a low resistance, making it easier for current to flow. The increase in the increase in temperature increases the number of free electrons available. There we go. So light dependent resistor, resistance decreases when light intensity increases, whereas for a thermistor, the resistance decreases when the temperature increases. And here are a couple of plots there. Okay, so as the amount of light on the light dependent resistor increases, then the resistance starts to go down, whereas for a thermistor, as the temperature goes up, the resistance goes down. Okay, those are the two examples there, comparing the two, a thermistor and an LDR. So, let's give you some letters. So again, pause the video now and try and fill in the gaps, and then we'll go through it together. Okay, so an electric current will only flow around a circuit if there is no gaps in the circuit. All components have resistance. The greater the resistance, the smaller is the current for the same applied voltage. And resistance, of course, is measured in ohms. A current voltage graph for a resistor is a straight line graph from the last lesson through the origin. This shows that the current through the resistor is proportional to the applied voltage. So that's Ohm's law and ohmic resistor. However, in this lesson we've learned about non-ohmic resistors. This is what this is going to be about. So the resistance of a filament lamp increases when the lamp comes on and the filament rises in temperature. A diode only allows electrical current to flow in one direction, so there's too much resistance. The other direction, the allowed direction, is shown by the arrow in the circuit diagram. Finally, the resistance of the thermistor decreases if its temperature is increased, and the resistance of an LDR is decreased or decreases if the resistance or light level is increased. And these are examples of non-ohmic resistors. So now we've learned about ohmic resistors which obey Ohm's law and non-ohmic resistors which do not obey Ohm's law. The next lesson will be about linking all this together with the differences in current, voltage and resistance in series and parallel circuits.